So you can see here we've highlighted that which statement is correct. So we're going for which statement is correct, and for different rates of hydrolysis. Now hydrolysis is dependent on bond strength. So we've got to break a bond to do hydrolysis, and so hydrolysis involves CCl, for example, being added to OH minus or water. Okay, and that is going to go to COH plus Cl minus. Okay, now if that is the case, you've got to break this bond right here, and we need that to break really, really easily. So what affects this? What affects this is the size of the atoms. So Cl and Br, we have a larger atomic radius. Okay, which means that the carbon-bromine bond might be that length, and the carbon-chlorine bond might be that length, because the larger the atomic radius, the less close these atoms can get to each other. Imagine two big balls like this. They can only get as close to each other like that, but a little ball like this, and a bigger one like that, you can see the distance between here and here is smaller than the distance between here and here. So the one I've drawn at the bottom could be a carbon-chlorine, the one I've drawn at the top could be a carbon-bromine. Okay. Now, if you've got a longer bond, a weaker bond, because of the larger atomic radius, that means this would be a stronger bond because it's shorter. And this will be a weaker bond. Okay, which means breaks easily with less energy. Which means the one that breaks easily with less energy will have a higher rate. So we're going to look for one that says the higher rate is with the BR. So if we look through this, we say, where is it going to say hydrolyte faster? We've got faster here on all of them. So if we look at faster like this, the CCl bond enthalpy is greater than the CBr. Okay, now bond enthalpies, right, are due to the fact you have a stronger bond. Another term for a stronger bond is a high bond enthalpy. If it's a high bond enthalpy, that means definitely your answer is B. We'll quickly go over why the other ones are wrong. A, hydrolyze fast because C is more electronegative. Electronegativity has nothing to do with it. Okay, so if you see electronegativity, you're just going to cross those out. RCl is hydrolyzed faster because CBr, well, RCl is not hydrolyzed faster. RBr is hydrolyzed faster, so that's wrong as well. Okay, and that is your answer to question number 1.